A fishing reel has a mass of 1.01 kilograms. Okay, this problem is dealing with a fishing reel that is going to be acting as a solid cylinder of a radius r. What's happening is that the fish is pulling out this way with a certain force, and there's also a frictional force of some sort that's pushing the other direction, also at that radius. So I've got a torque because of this force at this radius that's pulling out. I've got a torque because of this force at this radius that's pulling in the opposite direction, and I'm searching for the force of the fish. Now what I know is that the net torque is going to be the moment of inertia times the acceleration. So that's like F equals ma. So the moment of inertia is easy to figure out because it will be, it's a cylinder, a disk, so it's going to be 1 half mr squared. So I'm going to get a 1 half mr squared. And then the alpha, they give me the angular acceleration here of 50.7 radians per second. So that's my alpha. And my net torque is going to be the difference of the fish pulling, so that's going to be an RF minus the RF of the restraining torque. But they already give you what the whole restraining torque is, so this is 1.42 for me, is the whole RF here. So I know this R, I know I'm looking for the force. This RF is given to me. I know the mass and I know the radius, so I can use all of this and solve for the unknown force of the fish. The next question says, how much line unwinds in this amount of time? Well, now I can figure out, I know my alpha, I know my initial omega is 0. I'm looking for the amount of line, so I'm actually looking for an x. But if I can solve for theta, then I can use theta times r is going to give me x, or x divided by r giving me theta. I want centimeters. And then I know that my initial velocity is 0, and it gives me the amount of time, so I know time. So I've got alpha, omega, x, and t. Actually alpha, omega, theta, and t. And I know that theta is going to be my initial velocity times time, but that's 0, plus 1 half of my acceleration times time squared. So you can either you can either use your actual alpha and solve for omega and then multiply by r to get x, or you can take your alpha and multiply your alpha by r to get your actual acceleration, and then just solve for an x over here. So one way or another you're using this, but the key to this problem is knowing that there are two torques acting in opposite directions, one clockwise, one counterclockwise, and it's the difference between them that's causing the cylinder to rotate.